All right, for this section, we're going to combine two sections actually. 10.5 is over tangent lines, and then 10.6 is over tangent lines and secant lines. So we're just going to cover both of them together. So first of all, let's define what a tangent line is. A tangent is a line in the same plane as a circle that intersects the circle in exactly 1 point. You could even underline that, 1 point. And we call that point the point of tangency. So here's our circle over here. This would be our tangent line, and where it meets at that 1 point is called our point of tangency. All right, so we've got some theorems with tangent lines here. Let's look at our first one. Okay, let's see. All right, this theorem says, in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. All right, so it says in this picture, line L, right here, our tangent line, it's tangent to circle S if and only if it is perpendicular to this radius, ST. All right, so we can use that theorem in examples like this, for instance. So it says, in this picture, KL, right here, is a radius of the circle, and it says determine whether LM is tangent to circle K. Justify your answer. So using our theorem, we would know for sure that this is tangent to the circle if we could show that this right here was a 90-degree angle, because that theorem says if it's tangent, it has to be perpendicular to the radius. All right, so what could we do to show that that's a right angle? Well, one thing comes to mind, that's Pythagorean Theorem. I know that only works on right triangles, so let's test that out, see if it works. So we could say 20 squared plus 21 squared equals 29 squared. Let's write that out. Plus 21 equals 29 squared. Okay, so grab your calculator, see if that checks out. So we do 20 squared plus 21 squared, that gives me 841. Okay, let's see if we get the same thing on the other side. 29 squared, yep, I sure do. I get 841. So because they're equal, that means the Pythagorean theorem worked, which means this has to be a right angle. So by this theorem, that line has to be tangent since that is a 90-degree angle. All right, let's see what else we got here. Got another theorem. Let's see. And actually, before we get to that one, I'm going to put up a practice problem. You can pause this, but I want you to work through it, see if you get the right answer. It's based on what we just did. It's my computer screen. So go ahead, pause that right now, see if you can answer it. And I'll go ahead and reveal the answer now. Correct answer for this one is 12. So here you would have to set up Pythagorean theorem, right? You'd want to do x squared plus 16 squared equals, be careful how you name the hypotenuse, that would be x plus 8 whole thing squared. Okay, so if we kind of work through that, and I can show you right here. And if you got it right, then you can go ahead and skip this part. But working through that one, so we just said it'd be x squared plus 16 squared equals hypotenuse squared, which was all of x plus 8 squared. Okay, so check that out. So 16 squared gives us 256. Now over here, you'd want to FOIL this out. So this is x plus 8 times x plus 8. I'll go ahead and expand that for you. Okay, so you want to FOIL that. Let's bring this down again. So if you FOIL, you get x times x is x squared. I'm going to shorten it a little bit. I do x times 8 is 8x, and then 8 times x is also 8x. So I have an 8x and an 8x, which is 16x. Just doing a couple steps at once. And then 8 times 8 is 64. All right, from there we solve. I've got an x squared on both sides. I could subtract this from both sides, and my x squareds just go to 0. So I end up with 256 equals 16x plus 64. Subtract the 64. We get 192. divide both sides by 16, and that's how you get x equals 12. There you go. Okay, let's go on to this other theorem here. Okay, so this one says, it's a pretty simple one. It says if two segments from the same exterior point are tangent to a circle, so you've got like a tangent here, BA, and tangent BC, they're coming from the same point, then they are congruent. So in this picture it says if AB and CB are tangent to the circle, then AB will always be congruent to CB. So as long as they're both tangent and they come from the same exterior point, then they're going to be congruent. Okay, so that's pretty easy. So I'm going to put up a problem for you to solve based on that theorem. Here it is. So press pause, solve it. And the correct answer is 7. So here we go. They tell you these things are tangent. They're from the same exterior point, which by that theorem, I know those parts are congruent, so you just set them equal, solve for x. All right, nice job, guys. That actually covers the entire section 10.5. I'm going to stop this and make a new video for the rest of the notes, which is 10.6, starting with this definition here of a secant.